Okay, so you've got the question on the board since June 2014. The number of apps, blah, 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 in billions is dA dt is equal to 292A. Now, really, they're giving us two things. Y'all got it written down?
Yeah, I got it.
Yes.
Okay, so I'm going to go to my handy dandy. There we go. Okay, they give us this, and this right here, and we're going to highlight this. You need to highlight this. This right here is K. Okay, and this formula that they give us, basically is the derivative. It's going to yield us this formula. A of t is equal to a sub 0 e to the kt. And there is our growth formula. Okay, now I'm not going to show you the derivation of that because you don't need it. Just remember that when you see something like this, somewhere down the line, you're going to see a growth formula. And there it is. Now I'm going to substitute in for A, part A, they say 75 billion, which we already got billions. The whole thing is in billions. So that's going to be 75. I'm sorry. I messed up there. Erase that. That's going to be A of t is equal to 75 e to the 0.292 t. So that's my actual formula for this problem. Because A asks you for the equation. If you'll look back at A, it says, find the function, find the equation that satisfies the equation given approximately 75 billion apps were downloaded in 2014. Okay, now predict the number of apps in 8 years, which is 2000 and what? What did it say? 2022 or something? I can't remember what it said. What did it say?
Yeah, it was 2000.
Yeah.
Okay, 2022. And the difference is 14 to 22 is 8. So we all know that T is in years. So that means you're basically going to plug and chug. So B, how many in 8 years? So that's going to be A of 8 is equal to 75 e to the 0.292 times 8. And that comes out to be around 776. So 776 billion apps are going to be sold in 2022. Now we take that same thing, and it says in C, it says estimate the rate of change in the number of apps downloaded. Well, we've already got the rate of change. We already got the derivative. The derivative is what we started with. Okay? So that's going to be dA dt is equal to 0.292 times 776. And that's going to give us right at 226. Now, this is just plug and chug. There's no derivative. They already had the derivative. So there's no plug and chug. There's there's no derivative, just plug and chug. And you even plug and chug into the derivative because they want the slope, which is called the rate of change. Okay? So they want the slope, so we just did that. We plugged it in. So that means in June of 2022, you're going to download, or they're going to have 776 billion apps download with a continuing rate of 226 billion per year after that. 226 billion downloads per year after 2022. Now, I doubt very seriously that I will ask you a question like this on the test. I will tell you what kind of question I like, and you can go from there. If I like it, that means I'm going to put it on the test. Okay, so this is one example of what they're going to give you. Here, they gave you the derivative first, and of course, if you've given one like this, basically that big A right there dictates what this is. I'll just show you. This A right here, that big A, dictates what this is going to be. That's going to be big A. And then you put an X or most of the time these are going to be T's because we're dealing with time. How long does it take? And it dictates this. So if this was a B, this would be B of T is equal to B sub O. And this is your initial value. We'll get into that later. And then E, this whole thing right here, when you find the antiderivative, which we're going to do later, will give you an E to the KT power. Okay? So you'll see that in the next problem. You'll see me change it into this, and it'll follow along the same lines. Okay, let's do the next question. The next question. Intel, a computer chip manufacturer, reported blah, 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 blah million in total revenue in 1986. In 2016, the total revenue was blah, 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 blah. Assuming the exponential model, find the growth K, determine the revenue, R of T in billions, years after 1986, and predict the company's total revenue for 2025. So, first of all, write the question down. Now, since they gave you, do you see that R of T right there? They're telling you to start this equation off with R of T. That's what they're telling you. So that means that R, the initial value is going to be R sub O. And then you just add E to the KT. I wonder if I can. Okay, I guess I can't. I was going to try to highlight that. There we go. Well, okay, whatever. I was going to try to highlight it. Now I turned it white. So give it a second, and I don't know what it's doing. Well, forget it. I'm not going to try to mess it up. But I want you to take that R of t. I want you to take that R of t right there. I want you to highlight it, because that tells you how to set up your function. So I'm going to set up my function, and I'm going to minimize the I'm going to start off my function with R of t is equal to R sub O, and then I'll just put in the e to the kt. There. I just got the formula that I'm going to start this problem with. Now, they also gave us a couple of points. Okay, let me go back to the question. They gave us a couple of points here. They said Intel, a computer chip, reported 1,265 million in total revenue in 1986. In 2016, the total revenue was 59.4. Now, first of all, you got to compare apples to apples and oranges to oranges. What's the problem here? We got million and we got what?
Billion.
Billion. So you got to make them both the same. So I'm going to make that million into billions, and that's going to be changed to 1.265. So change that 1265, change it to 1.265 billion. So our 2 points are 0, because we're talking about since 1986. So 1986 would be 0. And 1.265, that's 1 point. And the next point is 30 years later, 59.4 billion. So there's our 2 points. Have y'all got the question written down? I'll take that out of the way. Make sure y'all got the question written down.
Yes.
Okay, now we got to find K first. That's what they're asking for. A says find K. So you've got to use what you've got to plug and chug. So here's what we're going to plug and chug. We know that the 59.4 is the outcome. 59.4 is what's in 2016. So that's your R of t. So here we go. 59.4 billion, 59.4 is equal to our R sub O. What was our initial start? Well, that's at 0, 1.265. 1.265. Okay. E to the K is what we're trying to find, and T is 30 years. So we just used everything over here. We just used everything. We used this for our outcome at the end of 30 years. That's what the outcome was. Outcome is Y. Okay? This is our initial ITIAL, I think. That's your initial Y. So it goes right there. And then 30 minus 0 is 30 years. That goes right there. So now we got to solve for K. Okay? So we just do an algebra now. So 59.4 over 1.265 is equal to, we're going to take the log of both sides, e to the 30k. Now I'm going to take the natural log of both sides. I'm going to do that in green. And how do I know to do that? Because I got an e over here. So the natural log of both sides (59.4) over 1.265 equals natural log e to the 30k. And the reason you took the natural log was so you could get rid of the e, and that 30k just falls down. So that's going to give you natural log of 59.4 over 1.265 is equal to 30k. And now I'm going to divide by 30 on both sides. So K is equal to, I got 0.1283. Okay, so usually it's going to be a decimal, positive or negative, and it's going to be usually rounded to 4 digits for your K. So now you can plug that back into the original equation. So R of T so I'm going to rewrite my original equation in green. I think I just did A. Yeah, I just did A. So you need to write that down. B. B, before I do B, I'm going to rewrite my equation. R of T is equal to 1.265 e to the 0.1283 t. There's your equation that you're going to solve B with. And B says, basically, let's go back and look at B. B says, determine the revenue function with R of T in billions of years, T years after 1986. Okay? T years after 1986. So what's 1986? I guess away from 2016. (1986) minus 2013. Is that 30?
2013 or 2016?
2016.
Yeah, that's 30.
Okay, so you're going to plug in 30. So go ahead and plug 30 in for T. So that's going to be R of T is equal to 1.265 e to the 0.1283 times 30. I did something strange in my notes. I don't know what I did in my notes. Let me check that right quick. All right. Point E, second natural log, parentheses, 0.1283 times 30, close the parenthesis. I hope I can't barely see it, this thing's so small. And then multiply that by 1.265. 1.265. I got 59.38, but that's not what I'm coming out with. For some reason, where did I get 39? I think I messed up something. I think you type in 30 there because it's 30 years. For some reason, I've got 39, and I don't know why. Maybe I was half asleep when I wrote them, or what? I don't know. Okay, so I came out right down 59.39. 59.39 is what I got. So R of T is equal to 59.39. Okay. Now, the main thing I want you to see about this question is right here. Take the natural log. Okay. That's why I wanted to show you that problem. Moving right along. Y'all speak up. I don't know how much of a delay we have, so. Here's another problem.
It's not too bad.
Not too bad? Okay, I'm going to kind of jump. I want to get to, I showed you the growth model. I want to get to the decay model. And there's a reason I want to get to the decay model. Where is the decay model? Here we go. Because that's where you're going to see some of your test questions. Let's go to the decay model. And let me get this down and go right here. There we go. The decay model is pretty simple. It's the opposite of the growth model. The decay model is P of T, and I'm just using some different variables. P of T is equal to P of O, same format, but instead of a positive KT, it's to the what? Negative KT. And you're going to see words like decay or half-life. You're going to see things like that. The curve, instead of going up like growth, it's going to be going down from left to right. So what I want you to be able to do, I want you to be able to discern between a growth problem and a decay problem. I want you to be able to take the natural log of both sides, and I want you to be able to take the derivative, which I'm going to get into with this one. Okay? So let's go to the problem. Go ahead and write this first problem down. I'll make it big where y'all can see it better. There you go. This is a standardized test question. Most of these decay half-life problems, they are standardized test problems. And you were probably going to see a growth problem and a decay problem. And when we go through the homework, I know y'all sent some homework, and I think I think you sent one, Miss Cox, and I think we're gonna cover it either this class or Thursday. So
Okay.
so just hold tight. Okay, again, they're giving us the derivative. So we're going to rewrite this one. This one's in form of n. See there? See that big N right there? The rate of change of an amount, N. So we know we're going to be dealing with N of T is equal to N sub O. So I'm going to go ahead and write that down. N of T is equal to N sub O. And then, of course, my E to the negative KT. So I've already got my function written down because of that N where it says the rate of change of an amount N. Boom. N of T, N of 0. N sub 0. Let me know when y'all get C written down. I'm going to go get my hair cut today. I'm going to get it all cut off. I'm getting tired of fooling with it. So I look kind of crazy. I got to get this hair cut off. I don't see how y'all girls stand it. But it's a good thing. Long hair on women, that's a good thing. But not on men. I can't handle it.
Well, the good thing is if it looks bad, nobody really has
So how's
So what'd you say, Miss Cox?
I said the good thing is if it looks bad, nobody really has to see you.
Yeah, that's true. What'd you say, Miss Billy?
I said, well, how's quarantine life going?
It's not a change for me because I stay home anyway. You know, I had my son last week, and he says, Daddy, we don't do much different than normal. I said, that's why you ain't crazy and you ain't stupid, because you don't hang around stupid people. No, I'm just kidding. And I said, that's why we don't have any drama in our life, because we don't hang around drama people, and we don't go looking for it. Now, I make an occasional run to Ingles and Walgreens over here on 24th. But other than that, I enjoy the heck out of it. But my family has always been that way. I mean, my family, and I'm not bragging or being modest or whatever, my family goes back, this farm I live on goes back like way back, like 5 or 6 generations. So we've always farmed. We've always farmed, and we've always done things we've done things, by ourselves. Just like I'm fixing a hay rake. I got the hay rake outside in my front yard. I've been working on it all week. And next I'm going to work on a tractor, and I'm going to fix the tractor and that kind of stuff. So I'm not very dependent on, now, when it gets real tough, I'll go shoot a steer, and I guess I'll have him cut up into meat if I have to, but I don't think it's going to get that bad. I don't think it's that bad anyway. I think people are getting sick, but I'll say it again, and this is just my opinion. I think China was tweaking this virus for population control, and they accidentally let it slip out before they had a cure.
I'm so glad you said that. Everybody else thinks I'm crazy for thinking that.
No, you're not, because think about it. Who is it killing?
It's killing like the older generation, so that's what they needed to get rid of.
And the unhealthy people. This was used as a population control. I don't care what anybody says. I don't care what anybody says. To the day I die, I will say that China did this to the world. They didn't mean to, but they did. So that's all I'm going to say on that. And let's go to the problem. Y'all got it written down?
Yeah.
Okay.
Yeah.
So I've already got mine written down. There it is. All I did is I took that n and I said, okay, that means n of t and n sub 0, and then I stuck the e to the negative kt on it because it said half-life or it said decay. That's why I put the e to the negative kt. A wants us to plug and chug. Get my mouse out of the way. All right, so that means that I'm going to give the definition, what we were given, n of t is equal to n of O e to the negative 0.0001297. 12097 n. Okay? Because that, no, T, I'm sorry, T. Because that first formula, d of n over dt is equal to negative 0.0001297 n. As I told you before, this right here is your K. That's your K. They're going to give you two things when they first start off. They give you what variable to write your terms in, and then they give you your K. And in B, they're going to give you something else. So in B, I think they said 800, right? So B, we're going to do n of 800. So we're just doing plugging and chugging right now. So, and I think they gave us 50 also. 50 e to the negative 0.0001297 to the t power. Uh-oh, we're going to have to find t, which means we're going to have to take the natural log of both sides. So first of all, we got to divide by 50. Wait a minute, I messed up. Shoot. I got the cart before the horse. I'm sorry. This right here is supposed to be 800. I was getting the cart before the horse. So don't divide by 50. Sorry. So n of 800 is equal to 50 e to the negative 0.0001297 times 800. And that comes out to be, when you do the math, I got 45.388. So after 800 grams of carbon, N of 800, or 50 grams, I can't remember what the question says, there is 45, after 800 years, there is 45.388 grams of carbon remaining. This is the one, and this is just like the one we did for the growth. C says, what does that mean? Well, we plug back into the rate of change, which is the derivative. D of n over d of t is equal to negative 0.0001297 times 45.388. And that gives us negative 0.0055 and that's grams of carbon per year. Grams of carbon per year. So basically, it's degrading at a rate of 0.005 grams per year based on that 800-year model. So after 800 years, you lost 43.388 grams, and it is decaying at a rate, well, this is grams, of 0.00055 grams per year. So at 800 years, you lost a lot. You lost what? 4.712 grams. After 800 years, you lost 7.12 grams, whatever I just said, 7 grams. And that the 45 that's left is degrading at 0.0055 grams per year. Okay? Next question.
Hubert, I have a question.
Yes.
You said this was a standardized test question, right?
Yeah.
Clemson has a math placement test I have to take when I get there, and
Yeah.
they make everybody take it. Would this be something that
Yes.
would be on there? Maybe.
Yes.
Okay.
This would be a question. Anytime I say standardized test question, yes, you need to write that down. Okay? And usually I try, and the reason this, decay, you're going to have a growth problem and a decay problem on a standardized test. Okay, this problem is just find the half-life for each situation. Okay, half-life, I haven't really showed you that yet, so go ahead and write it down, and I'll show you what it is after we write it down. Okay, so find the half-life for each situation. A population of bacteria decreases by 5.75% per month, and an element loses 1.9% of its mass every day. And we're going to get to a question here in a few minutes. Hopefully that'll where it brings everything home. Especially like the cooling, Newton's law of cooling. They know dead bodies. So in this case, let me pull up the handy dandy. Here is the formula for half-life. Kt, that's your exponent, is equal to the natural log of 2. So if you want to find K is equal to the natural log of 2 divided by T. T is equal to the natural log of 2 divided by K. You with me? So you can take this formula and you can divide by either one to get what you want. So the first one says K is equal to 0.0575. K is equal to 0.0575. So 0.0575 times T is equal to the natural log of 2. Well, there's only one thing I can do, and that's divide by 0.0575 to get T by itself. 0.0575, 0.0575. So T is equal to natural log of 2 over 0.0575. So T is equal to 12.055 months. 12.055 months, which is a little over a year. Okay, that's the first one, A. The second one, B, K is equal to 0.019. Plug and chug. This is K, so K 0.019 T is equal to natural log of 2. Divide by 0.019, divide by 0.019. T is equal to the natural log of 2 over 0.019, which I got 36.481 days. So to go back to the question, and I'll let you finish writing those down. And you're going to see this. You're going to see this later, okay? I think you're going to see these two, this one most, okay? But you're going to see these two later. So you pull up the handy-dandy question. The question said, a population of bacteria increases by 5.575 per month. So that means at about 12 months, the population of bacteria is going to be gone, or half-life, at half-life. Okay? An element loses 1.9% of its mass every day. So in 36 days, it's going to be at half-life. That's what they're asking. I mean, that's what they're asking for. All right. Next problem. Did I just do that one? I just did that one, right? That one. Okay, phosphorus 32. Phosphorus 32 has a half-life of 14.26 days. Find the decay rate for phosphorus 32. Of an initial amount of 1,000 grams, 100 grams of phosphorus 32, how much will remain after 90 days? So they are giving you your T right here. So we said, oops, sorry. So write that down, and all you have to do is plug in to whichever one you're not given. Okay? They're giving you T right here. So that means you're going to find K. Now that initial amount means that you're going to use your N sub O e to the negative KT, because they're giving you an initial amount. And you're going to learn that by the time you finish your homework problems. You're going to know that. So I'm going to take my handy-dandy drawer, and we're going to, the first one's going to be K equals to natural log of 2 over 14.26, because that's T. You were given T, So you use K is equal to natural log of 2 over T. And that's equal to 0.0486 per day. So you're losing about 5% per day. Whatever the question was asking. 5% of phosphorus 32 per day. B. N of T is equal to N sub O, and that's the initial amount. So when it said initial amount, you automatically, the little flag should go up and say, I'm going to have to use N sub O e to the negative KT. And what blew that up was when it said initial amount. We're going to plug and chug with what they gave us. The initial amount is 100. E to the negative, we just found negative 0.0486 T. Now remember, our T is days, because it's time, and our N of T is grams. Okay? So there's our formula. So N of T is equal to 100 E to the negative 0.0486 T. That's our formula. And I think in B, it asks, what if, let's see what it says. I think it says in B, how much will remain after 90 days? How much will remain after 90 days? So that means we're going to plug in N of 90 is equal to 100 E to the negative 0.0486 times what? 90. And that's going to come out to be 1.26 grams. So after 90 days, 1.26 grams will remain. After 90 days, 1.26 grams will remain. Now I know it may be seeming confusion right now, but what they're trying to get you to do is they're trying to get you to see the different parts of the formula. Okay? These problems are not going to be complicated once you do one or two. We haven't got to the actual problems yet. We're fixing to get to them. Okay? These are just kind of like drill problems. All right? These are not your problems that I will give you on the test. Okay? We're fixing to get to one right now. So you might want to write this one down as a test question or a standardized test question, because it has to do with, finding the value of a savings account. On Emma's 12th birthday, Emma's grandmother sets up a trust fund for her that will be worth $50,000 on the day Emma turns 21. Assuming that the interest is compounded continuously, that's PERT. A is equal to PE to the RT. We talked about that in 2.1. Assuming that the interest is compounded continuously at R is equal to 0.0375, what is the present value of this truss, which she starts it. Okay? Now, first of all, if you remember, I'll shut up and let you finish writing because I'm going to need to write on the thing. So let me know when y'all get through writing that down. And this is a question / standardized test question. You got it?
Yes.
Yeah.
Okay. Before I start, I want to go back to 2.1. Oops. I want to go back to 2.1, and I want to remind you, me telling you that we had compound interest, and that was A is equal to P times 1 plus R over N raised to the NT power. And then we had continuous interest, and continuous interest was PERT. A is equal to P e to the RT. Okay? E to the negative KT, P equals P of O. Now, a lot of people say, well, Hubert, interest goes up. We're not trying to find the interest. We're trying to find what Grandma started with to get to $50,000 when she gets to be 21. So we're going backwards. And that's why we're using the negative KT. Okay? So P of O is equal to PE to the negative KT, which basically is derived from PERT that you learned back in 2.1. So now, P of O is equal to blah, blah, blah. And we know that P from the question is equal to 50,000. We know that K is equal to 0.0375. And we know T is equal to, 21 minus 12? What's 21 minus 12? Dang old 9?
Yeah.
All right, plug and chug. This is nothing but a regular plug and chug problem. So P of O is equal to 50,000 times E to the negative 0.0375 times 9. And when you crank all that out, your initial value to put in the bank would have been $35,678. So wouldn't it be nice to have a grandma to give you $40,000 to $35,000 on your 12th birthday? Wouldn't that be nice?
Yeah.
I wish.
Yeah. I don't even think my grandmother gave me anything for my 12th birthday. Probably hit me upside the head. Or gave me a shot of bourbon, one of the two. I can't remember. All right. So that's a plug and chug question. So write that down and make sure you put that down for a test question or a standardized test question, because that's just, and again, you're adapting these problems to you're adapting these equations to your problem. In this case, this is a depreciation because you're trying to find what she put in at the beginning, so you're going backwards. Okay, that's why it's a negative instead of a, Now, if you were given, Grandma gave Emma $35,678 at 3.75% interest for 9 years, how much will Emma have? Then you would use this. Okay? Or, no, I'm sorry, you would use this. Because that is a positive direction because you're reading from left to right. But since they gave you what she gets at 21, and they want to know what did Grandma what did she initially, that's what piece of O means. What's the initial? Okay, so that's why it goes backwards with the negative, because you're going backwards to find what Grandma put in the bank. So it's the type of question. Here's another type question. It's a finance type question, not finance that you would think finance, but depreciation on a vehicle. Depreciation on a vehicle. All right, right. No, that's not it. There it is. A taxi service purchases a sedan and estimates that its salvage value, V of T is equal to V sub O, E to the negative KT. Boom. After T years is given by V of T is equal to, okay, they already did it, V sub O, which is 18,000, E to the negative KT. So they give you the formula. You don't have to plug in. Now, they say find the salvage value. Now, this is where, what is rate of change another word for?
Slope.
Slope. And how do we find the slope in calculus?
On the derivative.
Derivative. There we go. So this is our first question that we're actually finding the derivative of. So yes, this is a test question. So I'm going to go ahead and write down the initial V of T is equal to 18,000. Looks like the first thing is plug and chug, and the second thing is find the derivative. V of T is equal to 18,000 e to the 0.06 t. E to the negative 0.06 t. You got it written down?
Yeah.
Yeah.
We need to hurry because I want to get to those last questions. So I have 2 questions after this one. It's very important. So A, plug and chug. A, V of 3 is equal to 18,000 e to the negative 0.06 times 3. Well, I can do that in my head. 18,000 e, 3 times 6 cents is 18 cents. There you go. Now punch that in the calculator. And as you punch that in the calculator, I'm going to go ahead and set up the next problem, next part. No, yeah, B of T is equal to 18,000 e to the negative 0.06 t. And I want to find the prime of t. All right, so what did you get when you took e to the negative 18.18 and multiplied that by 18,000? That means I got 15,035. I'm going to round to the nearest dollar. Now, I've got to take the derivative of e to the blank t. Now, let me go over e to the x. E to the 1x is equal to, the derivative of 1x is 1, e to the 1x. E to the 2x is equal to 2, e to the 2x. E to the negative 2x is equal to negative 2, e to the negative 2x. E to the 0.05x is equal to 0.05 e to the 0.05x. So you're using the chain rule with each one of these. I took the derivative of 1x, that's 1. I took the derivative of 2x, that's 2. I took the derivative of negative 2x, that's negative 2. I took the derivative of 0.05x, that's 0.05. So this right here is all you're taking the derivative of. So that's going to be 18,000 or whatever. And that's going to be negative 0.06, because that's the derivative of 0.06t, e to the negative 0.06t. And that's going to equal, I got negative 1080. Y'all check me. Negative 1080 e to the negative 0.06t. And that's your formula for v of t. That's your derivative. And now you plug in v prime of 3. And I'm going to go ahead and skip because I think y'all can do that. I get negative 902. 902 is good enough. So that means that at 3 years, our taxi cab has depreciated $15,000. After 3 years, our taxi has depreciated. I don't know how to spell depreciated, but I'll do the best I can. Depreciated to $15,000, $15,035, and is decreasing what? $902 per year. That is a test question, so along with your first one. I'm not hurrying, but I want to get to this next question. Let me see what time it is. 0362. Let's see. It's 10:49, so I've got 10 minutes. Okay, Newton's law of cooling. That's where you got to do the dead body question. All right. D of T, D of big T over D of little t is equal to negative K times big T minus C. And that yields, if you do what we've been doing without doing all the, that gives us the function T of little t is equal to A e to the negative kt plus c. And this right here can be written as T sub O minus C. Okay? So this is Newton's law of cooling. Now let's go to the question. Go ahead and write that down. Let's go to the question because I need to get started on this one. You also do and if y'all don't mind, Miss Cox and Miss Billy, do y'all have anywhere to go after this?
No.
No.
Well, if we could cover these last two questions, it would benefit y'all. I think it would.
Okay.
I mean, it's not like we got 30 people that need to go to a class, all right, and having daggum convulsions like Pendleton campus does. No offense, Miss Cox.
No, it's okay. You're right.
Okay, so here is the question I'm going to give you. And yes, this is one that they do put on test. And it may be a dead body, it may be a cup of tea. But you're going to use Newton's law of cooling. So write it down, and then we'll do the dead body after this one. A freshly steeped cup of tea is poured into an insulated mug at 180 degrees. 180 degrees. Good golly molly. I don't like my drinks that hot, and I don't like my ice cream frozen. I'm weird. I put my ice cream in the microwave.
My sister does that too. It's so weird. I'm sorry.
Huh?
I said my sister does that too. It's kind of weird.
I know. I love it. I put like I'll get 2 or 3 scoops and put it in a bowl, and then I'll microwave it for 15 seconds and put magic shell on top of it. That's my favorite.
We used to have a plug-in heater in our old house, and during the winter time, if we'd have ice cream, and but the heater would be on, so I'd just put my bowl in front of that little heater and let it melt a little bit. Yeah.
So I'm not crazy. There's other people that like it, but I can't stand. If you give me a hot cup of coffee or tea, I'll just put it to the side. I won't drink it. I can't stand to drink extreme. I guess that's the way I am in life. I'm not into extremes in life either, so I guess that fits my personality. 180 degrees. I let that thing get down to about 100 before I drink it. The mug is taken outside where the temperature is expected to remain at a constant of 30 degrees Fahrenheit. An hour later, the temperature of the tea is at 75 degrees. Using Newton's law to create a model for the temperature of the tea in Fahrenheit, T minutes after the tea is poured in the mug. A. Find the values of A, C, and K in the model, expressing K to 4 decimal places. What was the temperature of the tea in the mug after 10 minutes? How long will it take the tea in the mug to cool to 120 degrees? Okay, so write that down. And we're going to be using T, big T of little t is equal to A e to the negative kt plus c. Newton's law of cooling. Now, 30 degrees sometimes is called the ambient temperature. In other words, it's what is surrounding the object, okay? You're going to see that it's called ambient temperature, like in a dead body question, or the temperature of the room is 72 degrees or whatever, 70 degrees. That is what is surrounding the object that you're talking about. Sometimes called C. That's what C is, 30. So, y'all got it written down?
Yeah.
Yes.
Okay. So, here we go. So, I don't know why I got it up in the roof like that. There we go. So, I'm just going to write out that A is equal to 180 minus 30. Remember the temperature minus the ambient temperature, C, which is equal to 150. And of course, C is equal to 30, and T is equal to 60, because you're talking about per minute. Big T is equal to 75. So the first thing you do, now remember this, because this is the first thing you're going to do with the, kind of like with the body temperature, dead body. You're going to say 75 is equal to 150 E to the negative K times 60 plus 30. Now I want you to solve that. Go ahead and subtract 30, divide by 150, take the natural log of both sides. That's all algebra. Now, I'm going to do it step by step for you. So 75 minus 30 is 45. 150 E to the negative K times 60. Divide by 150. Divide by 150. I'm going to leave it as a fraction because I got to take the natural log of it. So I might as well leave it as a fraction. So that's going to be E to the negative 60K is equal to 45 over 150. Now I'm going to take the natural log of both sides. And this is not calculus, this is algebra. 45 over 150 is equal to E to the negative 60K. And that natural log of E cancels that E out. And you're left with the natural log of 45 over 150 is equal to negative 60K. Divide by negative 60. Divide by negative 60. And K is equal to, if you do the math, 0.0183. 0.0183. So now I'm going to rewrite my formula. T of little t is equal to 150 E to the negative 0.0183 T plus 30. That should be, yeah, negative. Negative KT, so whatever you plug in for K is going to be negative. So this we're going to take into B. This is A. So I'm going to write that on the next page. T of T is equal to 150 E to the negative 0.0183 T plus 30. And now we're going to do B. And we're going to plug in 10. And that's going to be equal to 150 e to the negative 0.0183 to the 10 power, times 10. And I come out with, after 10 minutes, or I guess 10, I think it's 10 minutes. After 10 minutes, it's going to be, the cup of coffee or whatever is going to be at 155 degrees. Plus 30, I'm sorry. Plus 30. And that should be B. C, I think it's 120. Yeah. At what time will the cup be at 120 degrees or something to that effect? So C is 120 is equal to 150 e to the negative 0.0183 t plus 30. And of course, this is all algebra, so you're going to subtract, you're going to divide, you're going to take the natural log of both sides. So 90 is equal to 150 e to the negative 0.0183 t. 90 divided by 50, which basically reduces down to 3/5, I believe, but I'm not going to worry about it. So 90 over 150 is equal to e to the negative 0.0183 t. Take the natural log of both sides. I'm going to skip that step, and I'm just going to do natural log of 90 over 150 is equal to negative 0.0183 t, and that's going to give me natural log of 90 over 150 divided by negative 0.0183 is equal to t, and I think I come out with 28 minutes. So after 28 minutes, the whatever will be at 120 degrees. Okay, now we're going to do the body. So y'all finished writing that one down?
Yeah.
Okay, so here is, it's the same question. You just got to think in terms of the body. You got to think in terms of, instead of, like, they don't give you the initial temperature. What's the initial temperature of the body? 98.6. Okay, so you got to think about stuff like that when you're doing the problem. So write that down. And this is a test question. So I've already given you like 4 or 5 test questions just out of the decay section. A dead body is found at 6 p.m. with a body temperature at 80 degrees. With the room temperature, ambient temperature being 70, ambient temperature I think it's called, 70, 1 hour later, the body temperature was measured at 75 degrees. What was the time of death? So I'm going to rewrite it a little bit different. Same problem. T of little t is equal to the initial temperature minus the secondary temperature, e to the negative kt, plus the secondary temperature, or the ambient temperature, I think. No, yeah, the ambient temperature. I'll say ambient, but I think it's ambient. I ain't no dadgum CSI. I don't know. I'll have to look that up while y'all are writing. Ambient. Ambient. The ambient temperature. Ambient. So I was right. And it does have a T. Ambient temperature is the air temperature of any object or environment where equipment is stored. The adjective ambient means relating to intermediate surroundings. Ambient. So I did get it right. That gum blind pig finds acorn every now and then. Right? All right, so here we go. This is another way that you might see it written. And that's the same way we had, this was A, and I wrote T minus S, and then or T minus C, and this is C. So you see that the formula is not different. And here, what did I do with my, okay. So we're going to pick the closest, okay, we're going to say that the initial temperature, the closest one to his death, is 80. So 80 is going to be right there, minus 70, e to the negative k, t is 60, because it's 60 minutes, plus 70. Is equal to 75. So I just plugged in everything that they gave us. They gave us at 7 p.m. it was 75 degrees, and at 6 p.m. it was 80 degrees. Now the reason I picked 80 was because it's the closest to when the guy was alive, okay? Or the person. Just says dead body. Okay? So I made the 80 T sub O, and I made the 75 T sub T. And that is a good practice to get into. You want to put the closest temperature for the initial temperature. So that means we got to find K. So here we go. 75 minus 70 is 5. Equals 10 e to the 60 negative 60k. 5 over 10 is 1/2 equals e to the negative 60k. And of course I'm going to take the natural log of both sides. And that's going to give you 1/2 is equal to e to the negative 60k, and the natural e takes out the e, natural log takes out the e, and you're left with natural log of 1/2 divided by negative 60 is equal to k, and I got 0.0116 is equal to k. So I'm going to rewrite my formula, my equation, with k in it. So T, big T, little t, equals T sub O minus T sub S raised e to the negative 0.0116 t plus T of S. We're not finished. We just found our equation. We just found our equation. Now we're going to use that equation and plug in the next one. And this time we're going to use 98.6, which is his temperature when he was what? Alive. So next, we are going to use 98.6 equal to T sub O, and that means that our T sub T will be 80 instead of 75. So that means that we're going to be doing 80 equals 98.6 minus 70, which is C, e to the negative 0.0016 t plus 70.
Isn't it just 10, or am I wrong?
0.0116. Thank you. So 80 minus 70 is 10. 98.6 is going to be 28.6. E to the negative 0.0116 t. Divide by 28.6. And that's going to give us, that's going to go out. That's going to leave us, take the natural log of both sides. So natural log of 10 over 28.6 is equal to negative 0.0116 t. Divide by negative 0.0116, divide by negative 0.0116. So our time is equal to 90.59, which is equal to 91 minutes. And what is 91 minutes? An hour and 31 minutes? So what time did they get there? They got there at like, what, 6 p.m.? Well, somebody had to take the temperature of the body, so I'm assuming they got there at 6 p.m. So 6 o'clock minus an hour and a half, 1 hour and a half. Well, that would put it at what? 4:30. We still got 1 minute because we got an hour and 31 minutes. So our minus 1 minute is equal to 4:29 p.m. So the person was killed around 4:29 or 4:30. Now that question will be on your homework, and it'll be on test, and it'll be on standardized test. Because you know, a while back everybody was crazy about going into forensics. All the CSI shows that were on, everybody wanted to go in forensics. All right. Now, that is 2.4 and 2.5. So Thursday, I will be covering 2.5. 2.6. 2.6 is taking more derivatives. Okay? Y'all got a question?
Do you know when registration is supposed to open up?
It's already supposed to be open, I think. Did you go by to see your advisor?
Yeah, I've already went by and seen my advisor, but they said that they're they pushed it off because of all the e-learning stuff.
Oh yeah,
So I don't know.
forbid students. You know what? You know why they pushed it off? Because advisors don't know how to use Skype, and they can't Skype with students. That's why they put it off. And I've been telling them we need to be doing advising, we need to be doing financial aid, we need to be doing tutoring, we need to be doing all of that with Skype. We'll get around to it. Okay.
I kept getting about for your class and then an accounting class that I was supposed to be in. They're doing SI on Zoom this week.
Yeah. And the only reason I don't use Zoom is because y'all can use, I can't find you on Zoom. If I want to find y'all, I can find y'all because Skype for Business uses your Tri-County Tech credentials. So I can look you up. In Zoom, you can use donaldduck@gmail.com and I can't find you. So that's why I don't use Zoom. But I'm glad they're using SI with Zoom. Zoom is okay, but why would I use Zoom when all students have free access to Skype for Business?
Yeah, it doesn't really make sense.
It doesn't. And it's almost like, well, Hubert's using that, so we're going to use something else. So, I don't know. Y'all figure it out. Maybe you can ask them, say, why are y'all using Zoom when we have free access to, and they'll say, oh, well, Zoom is free too. Yeah, but you went outside of what we already had. I don't understand that thinking. But anyway, y'all have a good day, and I'll see y'all Thursday. Work on that homework.
Do you know when you're gonna make the 4.1